Imagine you are digging in the desert. The sun is hot, the sand is everywhere. You are sifting through the remains of a long gone city. It's hard work, but exciting. Every shovelful could reveal a piece of the past. This is what archaeologists do. And sometimes they find things that really make them scratch their heads. Not just an old pot or a broken tool, but something truly unusual. Something that doesn't quite fit the story we thought we knew. That's exactly what happened in 1936, and it's how we got the Baghdad Battery. The discovery happened in a place called Hujut Rabua. This site is very close to Baghdad in what is now Iraq. Back then, it was part of the Parthian Empire. This empire was incredibly powerful and influential. It stretched across a huge chunk of ancient Persia, controlling trade routes between the east and the west for centuries, roughly from 247 BC to 224 AD. The people there were skilled builders, artists, and engineers. They had sophisticated irrigation systems, impressive architecture, and a rich culture. So, when people dug up remains from this era, they expected to find fascinating things. But not this. The object itself isn't particularly flashy. It's a small, yellowish clay jar. Picture a little vase, maybe. It stands about 13 centimeters, around 5.1 inches tall. It has a slightly rounded, ovoid shape, typical of many ancient storage vessels. It's a modest size, something you could easily hold in one hand. But the inside is what caught everyone's attention. Inside the clay jar, there's a copper cylinder. This cylinder is about 9.5 centimeters, around 3.7 inches high, and has a diameter of 2.6 centimeters, about 1 inch. It was not just sitting loose, it was carefully held in place. The bottom of the copper cylinder was sealed with a disc of asphalt, a natural tar-like substance. And there was also an asphalt plug sealing the top, holding the cylinder firmly within the clay jar. Asphalt, remember, was a common sealing and adhesive material in ancient Mesopotamia, used for everything from waterproofing boats to cementing bricks. And then there's the third key piece. Inside the copper cylinder, suspended right in the middle, was an iron rod. This rod extended out through the top asphalt plug, protruding a little. So, if you picture it, you have the outer clay jar, then a layer of asphalt acting as insulation, then the hollow copper cylinder, then another layer of asphalt firmly embedding the cylinder, and finally the iron rod running down the center of the copper cylinder. Crucially, the iron rod and the copper cylinder are separated. They don't touch each other. There's a distinct space between them, a gap, where a liquid could easily be poured in. This precise layering of materials, each playing a distinct role in the assembly, made it stand out from a common pot. Wilhelm Koenig was the German archaeologist who was working at the Iraq Museum in Baghdad. He was the one who first really studied this peculiar artifact. He was a very experienced professional, but even he must have been taken aback by its unique construction. He looked at this strange assembly of clay, copper, iron, and asphalt, and a thought sparked in his mind. A very bold thought, really. He suggested in a paper published in 1938 that this object looks strikingly like a galvanic element. That's a technical term for an electric battery. Now, imagine the reaction to this idea back then. And even now, it sounds incredible. The established history of electricity credits figures like Luigi Galvani and Alessandro Volta with creating the first practical batteries in the late 1700s and early 1800s. That's nearly 2,000 years after the time of the Parthians. The idea that people in ancient Mesopotamia were messing around with electricity was, to put it mildly, revolutionary. It completely overturned what was thought possible for ancient technology. It implied a level of scientific understanding that simply wasn't supposed to exist until much, much later in human history. It felt like something plucked from a time machine. Koenig didn't just suggest it was a battery. He also proposed what it might have been used for. He thought it could have been used for electroplating. That means using electricity to put a thin layer of one metal, like gold or silver, onto another, cheaper metal. This would have allowed them to make objects look more valuable without using a lot of precious material. He pointed to some ancient silver-plated artifacts from Mesopotamia that looked like they might have been made this way. The evenness and thinness of some of these ancient platings were hard to explain with known techniques like fire gilding. This discovery in Koenig's interpretation immediately made the object famous, at least among certain circles. It quickly became known as the Baghdad Battery. It wasn't just a museum piece anymore. It was a subject of intense debate, a touchstone for discussions about out-of-place artifacts, things found in an archaeological context where they don't seem to belong. These kinds of artifacts challenge our timelines of technological development and sometimes hint at lost civilizations or forgotten knowledge. The Baghdad Battery became a powerful symbol for those who believe ancient peoples were far more advanced than mainstream history generally acknowledges. The careful and intricate construction of the Baghdad Battery is what makes it so intriguing. It's clearly not just a random collection of items thrown together. The specific placement of the copper and iron, kept separate by the asphalt, strongly suggests an intentional and sophisticated design. Someone put these parts together in a very deliberate way. It feels engineered, built for a purpose that goes beyond simple utility. A clay pot meant for storing grain wouldn't have an iron rod inside a copper cylinder sealed with asphalt. A simple decorative piece wouldn't be constructed with these particular internal components, chosen for their specific material properties. The question that hangs in the air is, what exactly was that purpose? Was it a genuine 2,000-year-old power source, a testament to an unrecognized chapter of ancient science? Or was Koenig mistaken? Was he seeing a battery where there was just an unusual but otherwise mundane artifact? This central question is what keeps the Baghdad Battery a topic of constant discussion and speculation even today. It forces us to look beyond our preconceived notions and consider what ancient people might have truly been capable of. The mystery has never really been solved, and that in itself is part of its lasting appeal. It sits there, a small, unassuming pot, asking us to rethink history, and that's a powerful thing. Alright, so we have this curious object. It looks like a pot, but it's put together in a very specific way with different metals inside. If it really was a battery, how would it have actually worked? It's not rocket science, actually. It's basic chemistry, the kind that was eventually formalized into what we now know as electrochemistry. The main idea behind any simple battery, often called a galvanic cell or voltaic cell, is to create an electrical current through a controlled chemical reaction. You need 3 key ingredients, 2 different types of metal, and a liquid that can conduct electricity known as an electrolyte. Let's break down the Baghdad Battery's components with this in mind. First, you have the iron rod. This would have acted as one of the electrodes, specifically the anode. The anode is the site where a chemical process called oxidation happens, meaning the metal loses electrons and corrodes. Second, there's the copper cylinder. This would have been the other electrode, the cathode. At the cathode, a process called reduction happens, meaning the metal gains electrons, or, more accurately in this case, positive ions in the electrolyte gain electrons and get deposited on the copper. For a current to flow, these 2 metals need to be chemically different enough to react in distinct ways with the electrolyte. Iron and copper fit this perfectly. They have different electrochemical potentials, creating an electrical difference. The third, and perhaps most vital, ingredient is the electrolyte. This is the acidic liquid that would fill the narrow space between the iron rod and the copper cylinder. For a simple battery like this to work, the electrolyte needs to be a substance that can carry a charge and react with the metals. In ancient, people wouldn't have had fancy lab chemicals, of course, but they had plenty of natural acids readily available. Think about what was common in Mesopotamia 2,000 years ago: wine, vinegar, and various fruit juices, like those from grapes or lemons. All these liquids are acidic. For example, vinegar is essentially a dilute solution of acetic acid. Sour grape juice contains tartaric acid. If any of these readily available acidic liquids were poured into the Baghdad Battery, they would have initiated a chemical reaction with the metals. Here's a simplified look at the chemistry. When the acidic liquid comes into contact with the iron rod, the iron atoms start to give up electrons. This process causes the iron to slowly dissolve or corrode into the solution as positively charged iron ions. These released electrons then build up on the iron rod. The acidic solution also contains positively charged hydrogen ions. These hydrogen ions are attracted to the copper cylinder. The electrons from the iron wanting to complete a circuit travel through an external wire if one were connected to the copper cylinder. Once at the copper, these electrons combine with the hydrogen ions from the acid, forming hydrogen gas bubbles. This continuous flow of electrons from the iron, where they are released to the copper, where they are consumed through an external circuit, is what we define as an electric current. It's that simple, at its core, creating a push and pull of electrons. The actual voltage generated by such a device would be small. This isn't a power plant. However, it's not insignificant either. Replicas of the Baghdad Battery have been made and tested extensively by scientists and hobbyists alike. When filled with common acidic solutions like vinegar, lemon juice, or even a saltwater solution which also acts as an electrolyte, these replicas consistently produce a voltage ranging from about 0.5 volts to around 1.5 volts. To put that in perspective, a standard AA battery, the kind you might put in a TV remote, delivers 1.5 volts. So, a single Baghdad battery could potentially produce a voltage comparable to one small modern battery. This is enough to cause a tingling sensation on the tongue or to power certain low current reactions. Now, one crucial aspect of the Baghdad battery's design is the asphalt. The asphalt plugs at the top and bottom served a very important purpose insulation and sealing. They physically separated the iron rod from the copper cylinder, ensuring they couldn't directly touch. If the two metals touched, the electrons would simply flow directly from the iron to the copper within the battery itself, creating a short circuit and generating no external current. The asphalt ensured that the only path for the electrons was through the electrolyte and, if connected, through an external circuit. This careful insulation points strongly to an intentional design for an electrical purpose. It's not an accidental arrangement. Someone knew how to keep the metals apart to make a specific reaction happen through a liquid. Could the Parthians have understood this? We don't have their textbooks on electrochemistry, of course. But ancient civilizations were incredibly practical and observant. They were masters of metallurgy, understanding how different metals reacted to heat and other substances. They produced pigments and dyes through complex chemical processes and made glass, ceramics, and alloys, all requiring a practical understanding of chemistry. They were keen observers of natural phenomena. It's entirely plausible that someone, perhaps by accident, stumbled upon this effect. Maybe a piece of iron was left in a copper pot with sour wine, and someone noticed a tingling sensation when they touched both metals simultaneously. From such an observation, systematic experimentation could have followed, leading to the refined design of the Baghdad Battery. Ancient people often learned through trial and error, not always through theoretical physics. If they wanted more power, ancient engineers could have done what modern battery makers do: connect multiple cells in series. Imagine several Baghdad batteries, each producing 1 volt. If you connect the iron rod positive terminal of one to the copper cylinder, negative terminal of the next, and so on, you could add up the voltages. 10 such batteries in a row could give you 10 volts. This wouldn't be enough to power heavy machinery, but it would certainly be enough for more noticeable effects than a single cell, perhaps even enough for primitive low-power lighting or stronger electroplating. The discovery of more than one such battery at the same site, or in close proximity, might hint at this, although even then, we don't have direct evidence of them being linked in a series. Comparing it to Alessandro Volta's battery, the voltaic pile, which was invented much later in 1800, highlights the similarity in principle. Volta stacked alternating discs of copper and zinc, separated by paper or cloth soaked in brine salt water, another electrolyte. Each copper-zinc pair was a cell. Stacking them increased the total voltage. The Baghdad battery, with its iron-copper arrangement and potential acidic electrolyte, operates on the same fundamental electrochemical principles. It's a primitive version, yes, but scientifically sound. This scientific plausibility is a major reason why the theory holds such strong appeal. It truly could have worked. Alright, if we accept that the Baghdad battery could, in theory, create a small electrical current, maybe up to 1.5 volts, then the next big question is, what would ancient people have done with it? They certainly didn't have light bulbs, radios, or electric cars. So, what useful purpose could such a small amount of ancient power have served? The ideas are varied and often quite imaginative, showing how creative people can be even with limited technology. These theories lean heavily on the idea that even a small, controlled electrical current could have a significant impact in a pre-electric world. The most widely discussed and perhaps most plausible use is electroplating. This is a process where you use an electric current to deposit a very thin layer of one metal onto the surface of another. Imagine you have a common object made of copper, bronze, or even lead. You want it to look like it's made of gold or silver, but gold and silver are incredibly expensive and rare. With electroplating, you could dip your cheaper object into a solution containing gold or silver ions. You connect the cheaper object to the negative terminal of your battery, the cathode, and a piece of the precious metal to the positive terminal, the anode. The electricity then helps to pull the precious metal ions out of the solution and bond them onto the surface of the cheaper object, creating a thin, shiny, and very convincing layer. Why would this be a good idea for ancient artisans? For economy and appearance. A thin, precisely applied layer of gold could make a humble copper statue or piece of jewelry look magnificent, creating an illusion of wealth and luxury. This would be incredibly valuable for jewelry makers, decorative artists, and especially for cult objects or temple adornments, where grandeur and precious materials conveyed prestige and devotion. And here's a crucial point. Archaeologists have, in fact, found some artifacts from Mesopotamia and other ancient regions that show unusual gold or silver plating. Some objects, particularly from the Parthian and Sasanian periods, have layers of precious metal that are remarkably thin and uniformly applied. This kind of application is difficult to achieve with older methods, like fire gilding, where a mercury gold amalgam is applied and then heated, burning off the dangerous mercury, or leaf gilding, pounding gold into thin sheets and sticking them on. Here, electroplating could offer a much more controlled, uniform, and durable finish without the dangerous mercury fumes associated with fire gilding. While it's hard to say definitively that these artifacts were electroplated electrically without specific telltale signs, the possibility remains open and gives the battery theory a tangible, practical application. Another interesting area is medicine. Ancient civilizations were often highly sophisticated in their understanding of the human body and different healing methods. They practiced surgery, developed complex herbal medicines, and even used animal-based therapies. For example, ancient Greek and Roman physicians were known to use electric fish, like torpedo rays, a type of electric ray, to treat various ailments. They would place the live fish on a patient's head or feet to deliver an electric shock, believing it could alleviate pain from headache, gout, or arthritis. This shows that the concept of using electrical effects for therapeutic purposes was not entirely alien to the ancient world. They understood that some shock could have a physiological effect. Could the Baghdad Battery have been used for a similar, perhaps more controlled, form of ancient electrotherapy? A mild electric current from a single battery or even a few connected batteries wouldn't be strong enough to cause harm. It would instead create a distinct tingling sensation, a mild shock, or a muscular twitch. This could have been applied to specific parts of the body using metal contact plates or even thin metal needles for a kind of primitive acupuncture. Such a sensation might have been believed to stimulate healing, relieve pain, alleviate nerve conditions, or even to provide a kind of invigorating charge to the body. The psychological effect, or placebo effect, of such a novel and perhaps mysterious treatment would also be powerful. If a patient believed a special electric treatment would help, it often did, providing symptomatic relief. So, the battery could have been a specialized tool for physicians, shamans, or spiritual healers. Then there's the mystical and religious angle. Ancient temples were often centers of both spiritual activity and impressive technological displays. Priests would sometimes employ clever devices to create miracles or enhance the awe and mystery of their rituals. Think about the famous engineers like Hero of Alexandria, who designed steam-powered temple doors, mechanical figures that poured libations, and fountains that magically moved water. If a small electric current could be harnessed, it could have been used in similar ways to impress devotees and reinforce religious authority. Imagine a priest inviting a worshiper to touch a sacred idol or an altar, and the person receives a subtle, unexpected tingling sensation or a mild jolt. This could easily be interpreted as a divine touch, a sign from a god, or a manifestation of spiritual power. Priests could have used the battery to make speaking idols, perhaps, by vibrating thin metal reeds with very low current, though this is highly speculative, or to create special effects during ceremonies that appeared miraculous. It's not about lighting up a room, but about creating an experience, a sense of wonder and awe that reinforces belief in the authority of the religious leaders. In a world where natural phenomena were often attributed to divine forces, a controlled electric spark or sensation could have been a powerful tool for spiritual manipulation, making a temple visit truly unforgettable and deeply impactful. Beyond these specific uses, there's the possibility of pure scientific curiosity. Ancient scholars, philosophers, and artisans were often driven by a desire to understand the world around them and to experiment with materials and forces. Perhaps the Baghdad Battery was not created for a specific practical application that we can easily categorize or that was widely adopted. Instead, it might have been an experimental device, an artifact of ancient scientific inquiry, an early form of a discovery toy. Someone might have discovered the electrochemical effect by accident and then consciously refined the design to better harness it, simply to see what it could do or out of intellectual fascination. This kind of experimentation, driven by curiosity and a desire for knowledge for its own sake, is a fundamental part of human innovation, and it's not exclusive to modern times. Other, more speculative, ideas have also been proposed. Could it have been used to power a very, very faint light source, perhaps for signaling in dark places, or to make something glow in a specific ritual? This is less likely given the technology of ancient lighting and the low voltage, which makes creating a visible light very difficult without highly advanced materials. Could it have been used to test the purity of metals, detecting impurities through slight changes in conductivity, or by specific reactions? Also possible, but more complex and less intuitive than electroplating or mild therapy. What all these potential uses have in common is that they don't require a massive amount of power. They rely on subtle effects, illusions, or targeted applications where a small current could still have a significant impact, whether practical, medicinal, or spiritual. The existence of these possibilities makes the battery theory all the more compelling. It means that if it was a battery, there were certainly things ancient people could have done with it that would have been meaningful in their lives. The question is not just could it have worked, but what would it have meant to them? And it shows how even a small, seemingly insignificant artifact can open up huge new perspectives on the richness and complexity of ancient human experience. Despite the exciting possibilities and the scientific plausibility, it's crucial to look at the other side of the coin. Many scholars and archaeologists are very skeptical about the Baghdad Battery theory. They argue that while the object could generate electricity, there's simply not enough evidence to prove it was intended to. And in archaeology, establishing intent matters a great deal. Without solid corroborating proof, the battery theory remains just that, a theory, an interesting hypothesis, but not a proven fact. And there are some pretty compelling arguments against it that cannot be easily dismissed. One of the biggest holes in the battery theory is the profound lack of supporting evidence in the broader archaeological record. If the Parthians were making batteries and using them for various purposes, you'd expect to find more of them. Not just one or a few, but enough to suggest a recognized and somewhat established technology. Yet, the Baghdad Battery remains a relatively isolated discovery. We also don't find any obviously associated electrical equipment. Where are the wires they would have used to connect these batteries or to conduct the current to the objects being plated or treated? While ancient wires made of copper or iron could have corroded and disappeared over 2,000 years, the complete absence of any metallic conductors in contact with the batteries is still noteworthy. More importantly, where are the appliances they would have powered? There are no definite artifacts that scream electroplated in a way that couldn't be explained by other, non-electrical techniques, nor any obvious tools designed specifically for ancient electrotherapy. We also lack any written text, drawings, or instructions from the Parthian era or surrounding cultures that describe the generation or use of electricity. This is a huge silence in the historical record. Ancient civilizations like the Greeks and Romans meticulously documented many of their technological innovations, like Hero of Alexandria's detailed descriptions of pneumatic and mechanical inventions. Why would something as groundbreaking as electricity go completely unmentioned and undocumented if it were a known technology? Then there's the issue of the low voltage and potential impracticality. As discussed, a single Baghdad battery produces only about 0.5 to 1.5 volts. To achieve any truly practical effect like electroplating on a noticeable scale, or to deliver a therapeutic shock with real impact, you would likely need many, perhaps dozens, of these batteries connected in series. Imagine the labor involved in constructing, filling, maintaining, and connecting so many small, fragile devices for a single task. Each battery would also have an iron rod that would quickly corrode in the acidic electrolyte, degrading over time as the chemical reaction occurred. This means the iron rods would need frequent replacement, making the whole operation quite high maintenance, time-consuming, and inefficient. While ancient crafts were often labor-intensive, the sheer inefficiency for a technology that would otherwise be revolutionary makes many people pause. Was the output worth the enormous effort required? Especially when simpler, albeit less advanced, methods existed for achieving similar results like fire gilding or contact with electric fish. So, if it wasn't a battery, what else could this peculiar object be? Several alternative explanations have been proposed, each trying to account for the unique construction and the materials used. One popular idea is that it was simply a storage vessel for special items. Ancient people stored all sorts of things, from grains and oils to precious documents and ritualistic items. The asphalt plugs certainly suggest a carefully sealed container, good for preserving contents from moisture or air. Perhaps it held a sacred scroll, a valuable spice, delicate papyrus documents, or even small seeds. The internal dimensions of the copper cylinder are indeed suitable for holding small, rolled-up parchments or thin scrolls. But if it was just for storage, why the specific internal structure of two different metals, copper and iron, separated in that precise way? A simple clay pot with an asphalt seal would have been sufficient for preservation. The advocates of this theory sometimes suggest the metals might have had a symbolic purpose, or perhaps they were just part of a more robust, multi-layered sealing mechanism. However, the specific separated arrangement of two different metals still seems remarkably over-engineered for simple storage alone, especially when simpler and more common storage containers were widely used. Another theory suggests it was a ritual object without any electrical function. In many ancient cultures, the combination of certain materials had symbolic or magical meaning. Clay, copper, and iron all had their own significance in ancient Mesopotamian cosmology or alchemy. Perhaps the object was a container for magical ingredients, or part of a specific ritual ceremony where the distinct metals were important for their inherent properties or perceived spiritual energy, not for their electrochemical potential. It might have been buried as a votive offering, a kind of dedication to a deity, or as part of a burial ritual containing something symbolic that was meant to accompany the dead into the afterlife. The context of its discovery in the ruins of an ancient village does not definitively rule out a ritualistic purpose, as such items were common in domestic and ceremonial settings. Some more creative suggestions include the idea of a thunderpot. This refers to a type of ancient sound device sometimes used in religious ceremonies or for entertainment, which might involve resonating chambers or other mechanisms to produce eerie sounds. But again, the precise internal arrangement of the copper and iron doesn't intuitively or neatly fit into this explanation any more than a regular shaped pot might. There would be simpler ways to construct a sound-producing pot without these specific reactive metals. Other archaeologists propose that it might have been used for a specific non-electrical chemical process. Perhaps it was a container for preparing or holding special alchemical solutions, or for a very particular type of fermentation or distillation. However, the exact design with the two distinct metals, especially with the copper being a hollow cylinder and the iron a rod within it, does not immediately suggest these processes either. The structure is too precise for general chemical work. It points to a very particular kind of interaction, and an electrochemical reaction is the most obvious one. A significant challenge for the battery theory is often referred to as Occam's razor. This principle suggests that among competing hypotheses, the one with the fewest assumptions is usually the best. The idea that this was an ancient battery requires a significant assumption that ancient Parthians possessed knowledge of electrochemistry that we have no other direct record of. The alternative explanations, such as a storage vessel or a ritual object, might be considered simpler because they rely on known practices and technologies of the time, even if they struggle to fully explain the specific internal metal components. Finally, there's the argument of coincidence. Just because an object looks like a modern device, or can be made to function like one, doesn't automatically mean it was one. Imagine finding a natural rock formation that remarkably resembles a human face. It might look remarkably like a carved statue, but it's just a coincidence of nature. Could the Baghdad Battery's striking resemblance to a galvanic cell be a similar kind of coincidence, an accidental arrangement of materials that just happens to work that way? This is a tough pill to swallow for enthusiasts, given the specific insulated structure that seems purpose-built for such a function, but it cannot be entirely ruled out by skeptics. The absence of compelling corroborating evidence means the burden of proof still largely rests on those who argue for its electrical purpose. And until more definitive evidence emerges, the Mabe, not a battery side will continue to hold sway for many in the archaeological community. After looking closely at the Baghdad Battery, examining its parts, its potential functions, and the strong doubts surrounding it, where do we ultimately land? The simple, honest answer is that we don't have a definitive, universally accepted conclusion. The Baghdad Battery remains one of archaeology's most captivating and enduring puzzles. It sits in a space between scientific possibility and historical ambiguity, continuing to spark debate and wonder among scholars, scientists, and the public alike. On one hand, the arguments for it being a battery are quite compelling from a purely scientific perspective. The physical design itself, two dissimilar metals, iron and copper, separated by an insulating material asphalt within a container clay jar, perfect for an acidic electrolyte, perfectly mirrors the fundamental structure of a simple electrochemical cell. The modern experiments with accurate replicas, constructed using materials available in the ancient world and filled with common acidic liquids like vinegar or fruit juice, consistently produce a small but measurable electrical current, proving that the device could have worked as a battery. And the proposed uses, such as electroplating for economic and aesthetic purposes, or mild electrotherapy for medicinal or ritualistic benefits, fit within the broader context of ancient ingenuity and cultural practices. It's not hard to imagine resourceful artisans or curious scholars discovering such a phenomenon and finding a use for it, even if limited. It would mean that a piece of technology we thought was invented much later actually has a very ancient, unrecognized origin. But then there's the other hand, heavy with the weight of skepticism and the absence of direct, irrefutable proof. The sheer lack of corroborating evidence is a significant hurdle for the battery theory. If this was a recognized technology, even a specialized one, where are the dozens or hundreds of other batteries in the archaeological record? Where are the associated wires, the electrodes, the clearly and undeniably electroplated artifacts, or the ancient text describing this amazing power source and its applications? The profound silence in the historical and archaeological record is difficult to ignore. Furthermore, the low voltage output and the rapid corrosion of the iron rod suggest a highly inefficient and high maintenance device, raising serious questions about its practical viability for any widespread or routine application. Many scholars argue that simpler explanations, such as a storage vessel for scrolls or a symbolic ritualistic item, are more consistent with the archaeological context and the known technological capabilities of the Parthian era, even if they don't fully explain the specific metal components. This ongoing debate makes the Baghdad Battery so deeply fascinating. It forces us to confront our assumptions about history and technological progress. We often like to see history as a steady, linear march of progress, with each invention building neatly on one another in an unbroken chain. The Baghdad Battery, if it was indeed a battery, powerfully disrupts that tidy narrative. It suggests that scientific understanding, or at least practical application of certain principles, might have existed in pockets far earlier than we commonly believe, only to be lost to time, waiting for independent rediscovery centuries later. It makes us wonder what other out-of-place artifacts might be waiting to challenge our timelines, or what other lost knowledge lies buried. The battery also highlights the inherent challenges of archaeological interpretation. When you unearth an object from millennia ago, you don't get a user manual. You get fragments, hints, material analyses, and a lot of room for educated guesses. The Baghdad Battery is a perfect example of how different, yet reasonable, interpretations can arise from the exact same piece of evidence. It teaches us humility about the limits of our knowledge of the past and encourages us to keep an open mind, even as we demand rigorous proof. It reminds us that piecing together ancient history is a bit like solving a giant, very old puzzle with many missing pieces. What we can definitively say is that the Baghdad Battery, whatever its true purpose, speaks to the incredible ingenuity and observational skills of ancient peoples. Whether they were experimenting with electricity or simply crafting a highly specialized container for something else, they were skilled engineers and problem solvers. The object itself is a testament to careful design and thoughtful material selection. It was made by people who thought deeply about how to construct something for a specific important function. It wasn't a random item, it was a deliberate creation. In popular culture, the Baghdad Battery has achieved almost legendary status. It often appears in discussions about ancient advanced civilizations, low technology, and even alien influence. Ideas that often stretch far beyond what archaeological evidence actually supports. While these extreme interpretations are mostly dismissed by mainstream science, they show the deep human desire to find extraordinary answers in the past. This artifact resonates powerfully with that desire, acting as a potent symbol for the idea that ancient people were perhaps much more capable and mysterious than we give them credit for. Ultimately, the Baghdad Battery might never give up its secret with absolute, undeniable certainty. We might never find the definitive ancient text or the perfect archaeological complex that unequivocally confirms its electrical function. But that doesn't lessen its importance. Its true legacy might not be in a confirmed technological breakthrough, but in its profound ability to spark curiosity, to inspire ongoing scientific inquiry and historical research, and to remind us that history is not a closed book. It's an ongoing discovery, filled with mysteries that challenge us to think differently and to keep exploring the vast, rich, and often surprising story of human innovation. It's a small clay pot that asks big questions, and that's a pretty powerful and lasting thing.